Hey everyone! Today we're going to learn a little bit more about concentration, and we're going to do just a little bit of math. It's not going to be anything too difficult though, so you guys should all be fine. We did a sort of activity last time about concentration, and now I want to write down the official definition of concentration. So we're going to write down concentration is a ratio. So it's a fraction. It's got a unit on the top and the bottom. And specifically, it is how much of a given substance is mixed with another substance. So we also want to know the terms concentrated. So if something is concentrated, it's got a large amount of solute. Remember, in a solution, the solute is the thing that you're dissolving. So if we're talking about salt water, the solute is salt. So a concentrated solution of salt water would have a lot of salt. And we also can talk about dilute solutions. Dilute means there is a small amount of solute. Okay, now there is actually a specific unit that we use in chemistry to measure concentration. Just like we have units for mass, our unit of mass is grams. We have units for volume. Our unit of volume is liters or milliliters. So our unit for concentration is something called molarity. So this is a very important word for this section. Molarity. And molarity is the moles of solute per 1 liter of total solution. So I don't know if you guys remember talking about moles. We've talked about moles before. A mole is a counting number. So if I have a mole of sodium atoms, I have 6.02 times 10 to the 23rd sodium atoms. I could have a mole of donuts. That would be 6.02 times 10 to the 23rd donuts. Now you don't have to use that number for these problems, but just so you remember what a mole is. So we're going to write down this definition as a formula. So we're going to write down molarity equals moles over liters. So if a problem is asking you to find the molarity, all you need to do is take moles and divide it by liters. One more thing that you want to write down, we do have a symbol for molarity. The symbol is capital M. It's important that it's capital M, because you're going to see here in a minute there's something else that's lowercase m. Okay, now I want to show you guys an example problem. I already wrote it out, so what I want you to do now is pause your video and take a few seconds and write down this problem so you can have it in your notes. So everyone pause your video now. Okay, so hopefully you paused and you wrote down this problem. This problem says, what is the concentration in moles per liter where 0.506 moles of Al2S3 has been dissolved in enough water to make 1.2 liters of solution? So first of all, notice in this problem it's asking me for concentration and it's asking me for moles per liter. So basically it's asking me for molarity. It's asking me to find this thing. Now it's really easy to find molarity because in these problems they're going to give you moles and they're going to give you liters. So for this problem, to find the concentration or the molarity, you would take the 0.506 moles and divide it by the 1.2 liters. And then you can do that on your calculator, and you can even do it on your phone. So I have my phone right here. I'm going to show you. So you just do 0.506 divided by 1.2, because that's what our fraction is. And I get 0.42. So 0.42. Since this is molarity, I can write it as capital M, or I could also write 0.42 moles per liter. Okay, same units, just different ways of writing them. The bigger your molarity, the more concentrated your solution. Okay, so hopefully that makes a little bit of sense. It's a little bit of math, but it really is just dividing. That's all you have to do to find molarity, is divide moles by liters. Okay, I want to tell you about one more unit of concentration that's really similar to molarity. So it's kind of a little bit confusing, but it'll be okay. It's almost the same, it's just one letter difference. So there's this unit called molality. So see, we just took the R in molarity and replaced it with an L for molality. And molality is another unit of concentration, but this unit is moles of solute, again, just like molarity, per kilograms of solvent. So instead of dividing moles over liters, to find molality, you're going to need to divide moles over kilograms. And we do have a symbol for molality, and it is a lowercase m. So that's the difference between molarity and molality. We've got an uppercase m and a lowercase m. Now, in case you're curious, the reason we have these two different units of concentration, the reason we have molarity and molality, is that molarity can change with temperature, because when things get hot, their volume expands, and so the molarity can be different at different temperatures. But molality does not change with temperature, because mass doesn't change when things get hot. So we use molality when we're dealing with things that are changing temperatures. So I'm going to show you one problem with molality, and then we'll be done. So here's the problem. So probably pause the video right now and write this down in your notes. So ready, pause it. Okay, so hopefully you got that written down. This problem says, what is the concentration in moles per kilogram where 3.4 moles of CuNO3 has been dissolved in 5 kilograms of water? So what I need to do to find molality, which again is moles over kilograms, is I need to take the moles that they gave me right here and divide that by the kilograms that they gave me. So we'll do 3.4 moles over 5 kilograms, and we will get, using our calculator again, we'll do 3.4 divided by 5, and I got 0.68. Since this is molality, we'll do a lowercase m, or you could write it as moles per kilogram. Okay, so that is molality. They're both pretty simple concepts. The only tricky thing is to not get them confused with each other. Just as a little bit of help on your homework, there are a few questions that will ask you to look at pictures and compare like which concentration or which pictures are more concentrated or more dilute. So I wanted to show you one like that. So look at this picture. It says rank these solutions from the least concentrated to the most concentrated. So you can see I've got some pictures of some beakers with little dots in them. So this one has 1 liter and it's got 6 dots. So that's 6 dots per 1 liter, right? This one has 2 liters and it's also got 6 dots. So this is going to be 3 dots for each liter, right? Since it's got 2 liters, each of those liters has 3 dots. This one has 4 dots per liter, and this one has 4 dots in 2 liters, so 2 dots per liter. So the least concentrated is going to be this one, so D, and then B, and then C, and then A is going to be the most concentrated because this one has 6 dots for every liter. Okay, so you'll need to be able to answer questions like that. I'm getting a text from somebody. So go ahead and let me know if you have any questions, and I will hopefully get to talk to you guys and see you sometime sooner than later. Have a good week.